All right, so we're going to go through some questions over Apex Prob Stats. This is 8.3.3, and I'm just going to start just going through them, okay? So this first one says, Pedro buys lunch at school every day. He always gets pizza when it's available. The cafeteria has pizza about 80% of the time. So I'm going to explain like where this simulation comes from, and this is important 80% of the time. Pedro runs a simulation to model this using a random number generator. He assigns these digits to the possible outcomes for each day of the week. Okay, so it says let 0 and 1 equal no pizza is available. Let 2, 3, 4, 5, 6, 7, 8, 9 equal pizza is available. Okay. The reason that they're using 0, like all the digits, is because there are 10 of them. And so let me write them out real quick. So if we say 80% of the time pizza is available, that would be 8 out of 10 of those numbers. So 2, 3, 4, 5, 6, 7, 8, 9. That's 8 out of 10. 80% of the time pizza is available. And then the other 2 out of 10, or 20% of the time, pizza is not available. So that's where these numbers come from. So they're saying 2 out of 10, 2 out of the 10 numbers, pizza is not available, represent that pizza is not available. And then 8 out of the 10 numbers represent that pizza is available. Okay. So I'm going to use a blue highlighter here to represent when pizza is available. And I'm going to use a red highlighter in my chart there to show when there's no pizza available. Okay. So these numbers in the generator, it basically, like in my view of this, how I kind of think of it is anytime there's a 0 or a 1, there's a possibility that no pizza is available. So like in this little box right here, there's no pizza available because there's a 0. This one has a 0 and a 1. This one has a 1 and a 0. The next one does not. The next one has 2 zeros. So again, I'm just kind of looking at anyone that has either a 0 or a 1 or both a 0 and a 1. Okay, so then I can kind of see there are only 3 boxes where there's not a 0 or a 1. So pizza is 100% available. Then it says, what is the estimated probability that Pedro will eat pizza for lunch every day next week? Okay, so every day, so for all 5 days, it's saying like in this box right here, this one I just circled in blue, all 5 of the days pizza was available. In this box, all 5 days pizza was available. In this box, so 3 out of 10 of the simulations would show that pizza is going to be available every day. So 3 out of 10, that would be our fraction. That's also 30%. Or I think in this one, the answer is actually written as a decimal. So we can represent probability using a fraction, 3 out of 10, a percentage, which is 3 out of 10 is 30%, or the decimal version, which is 0.3. Okay? All right, so that's your first one. Okay, question 6. I think this one was a little bit confusing, just based on the numbers that were generated. I didn't really know where they were coming from. So it says, suppose the following set of random numbers is being used to simulate the event that a basketball player is making 5 free throws in a row. So it generates numbers, and it's saying like, okay, the first set of 5 numbers is like those 5 free throws, okay? Then there's another set of 5 numbers. Then there's another set of 5 numbers. Then there's another set of 5 numbers. So everything that's generated, every time they do the simulation, it's going to have 5 numbers that represent the 5 free throws that he's shooting, okay? It says, how should the numbers be rearranged? So if you look at this, it looks like in the original list, it's not 5 numbers at a time. It's actually 6 numbers at a time. So 8, 6, 0, 5, 8, 3, there's 6 numbers there. 7, 8, 5, 8, 1, 4, there's 6 numbers there. So we need to look for, in our options, A, B, C, or D, which one has just 5 numbers listed at a time. So if you go through, this one has 6 numbers. That's like our original list. So 6 numbers, 6 numbers. This one has 4 numbers, then the next 4 numbers, then the next 4 numbers, then the next 4 numbers. So that can't be right. This one has 5, 5, 5, 5. So each of those has 5 numbers, and this one has 3 numbers. So it has to be this one, just because we're looking for which option is going to show us the 5 free throws. Okay? So that really is our only option there. All right, next one. Corey is a bird watcher. He estimates that 30% of the birds he sees are American robins, 20% are dark-eyed juncos, and 20% are song sparrows. He designs a simulation, okay? And so again, kind of similar, he's saying based on all of the digits, if 0, 1, and 2, so 0, 1, and 2 represent American robins, that's 3 out of our 10 digits. 3 out of 10 digits represent American robins. That's 30%, which is what he originally said, okay? Then we have 3 and 4 represent dark-eyed juncos. That's 2 out of 10, or 20%. Then we have 5 and 6, that's also 2 out of 10, represent 20% of song sparrows. Then the rest of the digits, oops, I already used that color. The rest of the digits, so 7, 8, and 9, are just other birds. So 3 out of 10 digits are other birds, okay? So 30%, 20%, 20%, 30%. That would all add up to 100%. Okay, so then you see the simulation. It says, according to the simulation, what is the probability that at least one of the next 5 birds he sees is a song sparrow? So that was right here, 5 and 6. So if we want to know what's the probability that at least one of the next 5 birds is a song sparrow, we're just looking for at least 1 5 or 1 6 in our box, okay? So I'm going to highlight in green the boxes that have a 5 or a 6 in them. And I'm just going to go, every time I see a 5 or a 6, I'm going to highlight that whole box. So all these have a 5 or a 6 so far. Goodness, there's a lot of them. And then again, because you just have one shot at this, I would just make sure very quickly, like do a double check here and make sure you highlighted the ones with a 5 or a 6. So here, this has a 5 and a 6, a 5. That one doesn't. This one does. This one has a 6. That one doesn't. We got a 5. We got a 6. We have a bunch of 5s and 6s. A 6, a 5, a 6. No, no, a 5, no. 2 5s, no, no, and a 5. Okay, so we did it accurately the first time. So now how many of those boxes are there total, and how many did we highlight in green? So if I count the green boxes, I have 1 2 3 4 5 6 7 8 9 10 11 12 13 out of a total of, I have 5 boxes across and 4 boxes down. That's 20 simulations. So 13 out of 20, okay? And then let me check and see how Apex actually has your answer here. Okay, they have it as a decimal. So 13 out of 20 is 0.65. Would be the probability that at least one of the next 5 birds is a song sparrow, okay? All right. Okay, so on to the last one here. The following set of random numbers represents 20 simulations of 3 daily flights from Philadelphia to Seattle. And I already kind of wrote this down because the information was, I thought, hard to find. So right here it says 0, 1, 2, or 3 representing a late departure. And then 4, 5, 6, 7, 8, 9 representing an on-time departure. Okay? So late versus on time. How many of the simulations was there an on-time departure for all 3 flights? So what we're looking for is like a set of 3 numbers. So kind of, maybe I'll do it this way. I'm going to separate right here with a line, like after 3 numbers. So it's kind of in groups of 3, but they're very tight together. So I just don't want you to, you're looking at 3 numbers at a time because it's 3 flights from Philadelphia to Seattle. Okay. So what I'm going to do is highlight just each group of 3 numbers that has only 4, 5, 6, 7, 8, 9. So I can't have any 0, 1s, 2s, or 3s. So you know what? I'm just going to cross off the ones with 0, 1, 2, or 3. 0, 0, 2 there. There's a 3 there. There's a 1 and a 2, a 0 and a 2. Okay, so then this does not have a 0, 1, 2, or 3. This one doesn't. This one doesn't. This one doesn't. This one doesn't. So 1, 2, 3, 4, 5 times there was just a 0, 1, 2, or 3. Again, I think the hardest part about that is just being very careful and like double checking your work, okay?